positive.
Recording in progress.
So now I switch and I'm positive. And I will say majority of the time at each of these like critical points, the sign should switch, but that is not always true. So just be careful. That's why we check. Okay, now we have 9. So I have a -2 times 9 minus 8, which is a positive, over 9 minus 7, which is positive. So this goes back to being negative. Okay. So now that I know this, I want to say what the heck is my solution? Okay. And remember, I am strictly less. So I am not equal to 0. So I know that these two, I cannot include those, right? But then remember, I want negative. So I would go in opposite. I would not go in between. I would go in opposite directions. So my actual solution, if I'm going to write it kind of nicely here, is, here, first, I'll draw the line maybe, and then I'll write interval notation. So it's going to be the parentheses, right? And then this way, and then kind of bold this, right? And if I write this in interval notation, this is -infinity to 7, parenthesis, right? Union, we're combining 2 intervals here, 8 to infinity. And there's our answer. Okay. Oh, and sorry, somebody said, haven't missed a quiz. Yeah, no, you haven't missed anything. Sorry, whoever, that was maybe a few minutes ago, but thank you for answering, Ivy. Okay, so we have one more. This last question is not as much solving. It's just, well, it is solving, but it's finding the domain. So it's just a little bit, it's in a little bit of a different way, right? So we're going to find the domain here. We have f of x is this square root, right? This square root function with a fraction, a rational function. Oh, okay. So sorry, German asked a question. What answer do I want? So I'm writing it like this right now, but on the test, I will take either. You only need to give like one answer. So you could give just this one, you could give just this one. And if it asks specifically interval notation, then that just means you must give this answer, if that makes sense. Some of the questions on the test will ask, like, please write your answer in interval notation, or please write your answer like this. And so, or on a number line or something, right? And that just means this way or this way. But if it does not ask, I will accept either. Okay. So hopefully that answered your question. Okay. Now, when we're looking at this domain one, well, I know that we can never divide by 0. So I look at this and I kind of say, oh, well, x can't be 5. I know that's true, but it's inside a square root. So I know we want to take this, and I know that this whole fraction has to be bigger than or equal to 0, right? So now we basically have, I wish I could, how can I scroll? Maybe I could add a page. Okay, I can't get fancy here, but if you can't see this, let me know, or maybe, I'll move this over here. Okay, perfect. So now I have a new problem, right? And I'm going to write this problem out. I have 2x over x minus 5. I want it to be greater than or equal to 0. So now this is my, I already have 0, good to go, and I have greater than or equal to, right? Because I know that in square root, we can't have negative numbers. Okay. So then I also want to notice that here, x cannot equal 5. So 5 is not in the domain. So I'll just keep that in mind. And again, we're going to do this in interval notation and the line, but I would accept either. You can pick your favorite one.
I had a question. For this one, could we just go like looking at the problem? Could we just go straight to the interval or number line
definitely.
notation?
Yeah. So you don't need to write like this right here, what I did, right? You could just say, okay, draw my line. You could say, I know that, like, because you might already know this has to be bigger than or equal to 0. So
Right.
if you just do the line and your critical points are 0, because when, like, that's when the numerator is 0, and 5. So you could say 0 and 5, and then you could just kind of get right to it,
Okay.
right? Yeah, that's fine. Okay, I'm gonna write my test points though. And maybe I'll just write them. Okay, hopefully you can, I know this is really low on the screen, but hopefully you can still see it. So my test points are gonna be maybe -1, 1, and 6. And I'm not gonna write out, I won't write out as much detail here, but if I plugged in -1, I get a negative in the top and a negative in the bottom, which means I'm just positive, okay? If I plug in 1, I get positive in the top, but negative in the bottom, so I'm negative. And then if I plug in 6, I'm positive, it, like, that would be 12/1, so I'm positive everywhere. So now what I can do is I can find my, I can write my answer as, so, okay, let's see, what can I cannot include 5, remember, so this is gonna be a parenthesis. And then I want all the positive places, so then I'm gonna go this way. And then I can include 0 because it could equal 0. Square root of 0 is 0, that's fine. So I can put a bracket here. I'm also skipping my circles and dots, but and then I want everything positive. So we just cannot include, I wouldn't write that X, but we can't include what's in the middle. And then if I want this in interval notation, my answer would just be -infinity to 0, union 5 to infinity, right? Okay, and I think I'm caught up in the chat.
So there's really nothing we have to do different to this, even though it's got a square root.
No, so yeah, this one, it's just showing you that this is another way to do the same thing, asking a different question. So like it's asking the question in a different way. It's saying find the domain. So technically, like this, this would be the domain of f of x, right? Whereas before we were just solving like what could x be. I mean, I guess if they were a function, we were kind of solving for the domain, but we were solving for the solution, because in the previous problem, the solution means that for any of these values of x, this fraction is less than 0. So we're just solving for this inequality. Or for any of those values of x, actually, this fraction is less than 3. We know that because we derived because we derived, this guy from this guy, we basically found a solution for this one by using the other one. And so we were finding solutions before, whereas this problem is just finding a domain, but you are doing the exact same thing and your answer looks very similar. Does that make sense?
Yes.
Okay. And I don't know how the homework asks it. I think it asks it kind of in both ways. So yeah. Okay. So those are all of the notes. And what was the purpose of the radical? Like the square root, you mean? David asked a question. Like the purpose in number 11 of why do we have square root? It's just the function. I think that's what you're asking. Like what's inside the radical, right? That's what you're talking about? Yeah, is there no plus or minus answer? Okay. Well, so I think what German is asking about is like typically, right, I don't really have space for this, but maybe I'll just, oops. Typically, if you have something like x squared, equals 9, and you take the square root of both sides, you have like plus or minus square root of 3, right? Or, okay, oops, plus or minus square root of 9, which is plus or minus 3, right? Yeah, that was my bad. In this case, they're only giving you the positive 1. We're only concerned because the function is already we're not taking the square root. We're saying the square root is already there. We just want to solve what is the domain for the inside of that for the inside of the square root. Hopefully that answers both of those questions. I'm not really sure.
I think for 11, that square root just makes it so that we have to use an inequality.
Yeah,
that's why the square root's there. Yeah.
Yes, it's really just so that, yeah, exactly. It's really just so we use an inequality. Yep.
I have a quick question. So I can see why on number 11, why 5, when you do number line, 5 is like an asymptote, But
yes.
Why is 0? Can you explain how you came up with the 0?
So 0 is, yeah. So 0, it's not going to be an asymptote, right? But 0 is a critical, we call these like critical values. And 0 is a critical value because the way that I get, so the way that I get like this point and this point, right? These two points is by setting the numerator and denominator equal to 0. If I have one fraction, right? Which is why in number 10, we had to subtract the 3 and then make it all one fraction. And then I set the top equal to 0, the bottom. And that's how that's always how, like 7 and 8, that's how I got those. 0 and 5, that's how I got those. So
you would say 2x is equal to 0 divided by 2.
Exactly. And 0 divided by 2 is just 0, right? So the 2 in this case doesn't even really matter.
Right. Okay.
Yeah. Yep. Yeah, good question.